Hi everyone! In this video we're going to look at assigning oxidation number. Oxidation number is going to be important when we're looking at redox reactions and whether or not electrons have been gained or lost by specific elements. So when we look at compounds or pure elements, we need to be able to determine the oxidation state. So there are four basic rules that we are going to go through when looking at elements and determining their oxidation number. The first rule is that the elemental form of an element will have oxidation number of 0. So if we look at something like elemental sodium metal, this would have oxidation number of 0. If we look at F2, F is a diatomic element, so it comes as F2. The oxidation number of each fluorine atom in that is 0. The second rule is dealing with monoatomic ions, that is, an individual atom that is charged. The oxidation number will equal the charge of that ion. So in another example, we could have Na+, we have that formal positive charge, the oxidation number now is +1. And if we had Br-, the oxidation number for this would be -1. So oxidation number can be 0, or it can be positive integer or a negative integer. The third rule is helpful for when we need to determine the oxidation number in compounds. So this rule tells me that the sum of the oxidation numbers must add up to the charge of the compound. If we have a salt like NaCl, the oxidation number of sodium plus the oxidation number of chloride must equal 0, because NaCl is overall a neutral unit. If we have a molecular compound like ammonia, NH3, we take the oxidation number of nitrogen plus the oxidation number of hydrogen. There are 3 of them, so we've got to multiply that by 3, would all add up to 0. For polyatomic ions like PO4 3-, the oxidation number of phosphorus plus the oxidation number of oxygen times 4 of those must add up to -3 because the charge is 3- there. All right? When we're assigning oxidation numbers to individual elements, we're going to follow this order of priority that we're going to work through. And it is okay if we violate a rule at the bottom of this list. So we're going to follow this in order until we have to apply rule number 3, which states that the oxidation numbers must add up to the charge of the molecule. So let's get started and see what this looks like. So the fourth rule will say is common oxidation numbers for elements in compounds are as follows. Group 1A, those are our alkali metals, will always have in compounds an oxidation number of +1. Those elements in group 2A will have oxidation numbers of +2. This should make sense. These like to form ions of the +1 and +2 type. So compounds like sodium chloride, we'd have Na having oxidation number of +1 and chloride -1, so that the sum must equal 0. We have magnesium bromide, Mg would be +2, Br would be -1 each. There are 2 of them, right? So this would be -1, -1, plus 2 would add up to 0. Okay, so the sum of the oxidation numbers will equal 0 for a neutral compound. For compounds involving fluorine, it would be given priority and assigned oxidation number of -1. An example of this would be HF. So we would assign fluorine first, okay? And when I say group 1A, this is not including hydrogen. all the metals below it. So we assign F first. We'd say, well, F is -1, so in order for this to add up to 0, hydrogen must be +1. Okay. The next most important is hydrogen, and typically has oxidation number of +1. Then we would assign oxygen, which is typically -2. Then we'd move on to 7A, the rest of the halogens. These are typically -1. 6A, the rest of the oxygen group, typically -2. And then 5A has the lowest priority, which would be -3. So let's look at some examples of where we can apply this list in order and where we may violate one or more of the rules below so that we can satisfy rule number 3. So we need to follow these rules in order, and it's okay if we break one that comes after those in the list here. Let's use NO2 as an example. So we know that this is overall neutral, so the oxidation number of nitrogen plus the oxidation number of oxygen times 2, there are 2 of them, must add up to 0. We would assign numbers in order, so we find oxygen first would be -2. So we can actually set this up as an algebraic equation and solve for this. So this equals 0. If this is -2 times 2, that would be -4. So oxidation number of nitrogen would have to be +4 for this to work out to 0. Right? So nitrogen would be +4, oxygen would be -2 each. How about hydrogen peroxide, H2O2? Okay. Well, we follow the list in order. H would be assigned first as +1. So the oxidation number of H times 2 plus the oxidation number of oxygen times 2 equals 0. So +1 times 2 plus oxidation number of oxygen times 2 equals 0. So +2 plus, then it would have to be -1 to equal 0. Okay, so oxygen would be -1, hydrogen would be +2. So here's an example of where we follow the list in order. We assign hydrogen first, and then oxygen violates what is commonly found for oxygen. And these are just a list of common ones. And empirically, this is what we see most often, -2 oxidation state, but there are, of course, exceptions to that. Another one we'll look at is the fluorine derivative of hydrogen peroxide. So we would have a Lewis structure that looks like this. And we can assign the oxidation numbers the same way. So the oxidation number of fluorine times 2 plus the oxidation number of oxygen times 2 equals 0, the charge. Okay? So we assign fluorine first as -1, so -1 times 2 plus the oxidation number of oxygen times 2 equals 0. So we've got -2 times, we'll call that x, times 2 equals 0. So 2x equals 2, so x must equal 1. The oxidation number of oxygen must be +1 in order for this to work out appropriately. Keep in mind that oxidation state is not the same thing as the charge. The oxidation state is a simple way of keeping track of electrons gained and lost in redox processes. So we can apply this assignment of oxidation numbers to reactants and products to determine whether or not a reaction can be classified as redox, meaning that electrons have been gained or lost by chemical species. So give a couple of the triads a try and let me know if you have any questions. Thank you for watching.